Okay, just as a quick catch up, I know Rossi, you've been away, but they've been going up on YouTube. Last week, remember that we got to foil, first out as in as last, that was explained. Okay, my understanding is that most of you had an opportunity to try foil. Hands up if you've at least attempted to try foil, first out as in as last. It's nearly all of you. Okay, so that was distributive law, which number, 2 or 3? 2. And I don't think I went through the difference of two squares. Okay, so distributive law 3 is what we're looking at here. So if you open up to your glossary, please. Distributive law 3 is known as the difference of two squares. Okay, the difference being the plus and the minus sign. Okay, maybe I shouldn't have asked you to do that. So if you just pay attention this way, sorry. The difference of two squares, when you've got these the same and these the same, okay, A's the same, B's the same, and they're just separated by a different sign, difference of two squares, okay, all you need to do is to square the first number, square the last number, and subtract. Okay, it's a rule, we just need to follow the rule. A plus and a minus, plus multiplied by a minus, so remember that there's a multiply in there. A plus multiplied by a minus equals a negative. So we should know that, and all we're doing is squaring the first number we see, subtracting from the square of the second number. Let's have a look at a question. This rule, I think you'll find relatively simple. Okay, example, exhibit A. Same first number, same last number, separated by a plus and a minus. Okay, so it must be a minus because we are multiplying these. We are multiplying these. It doesn't matter if the number comes first or if the letter comes first. We are squaring what we see at the start. We're squaring what we see at the end. Okay? It just saves you, folks, doing FOIL with this process. FOIL, those of you that have tried it, takes quite a long time, doesn't it? First out as in as last. You could do first out as in as last on this. I'll just quickly prove to you why FOIL, the difference of two squares is a quicker version of FOIL. So, Maddie, if you can pay attention, please. So, Damo, what are our firsts? We're going to do this one here. What are our firsts here? 3 there. Yep. No. Anything else? Sure. No. Good trying. Emily? 3 and 3. Yep. 3 times 3 will give us 9. Okay. So our firsts are done. Firsts. Now we're up to our outers. Charlotte, what are our outers here? The Y's. Not quite. Yeah, alright, so some of you need to retrace your steps. I know I'm hitting you up really early on a Monday morning. Reese?
3 and the positive Y.
Excellent, well explained. The 3 and the positive Y are outers. Remember, they're on the outside. Okay? 3 multiplied by Y gives us 3Y. What therefore are our inners, Jordan?
Negative Y and 3.
Negative Y and 3. Our inners, they're on the inside. Negative Y multiplied by 3. We do the sign first. Negative multiplied by positive gives us a negative. We do the numbers second. 3Y. And last, what are our lasts here, Lockie?
The positive Y and...
Yes. Yep, good trying, good trying. Tish, you want to help out there?
The negative Y times positive.
The negative Y, they're last in this bracket and they're last in that bracket. So I reckon you were nearly there. Negative times a positive gives us a negative. Y times Y is Y squared. Okay. We've got positive 3y, take 3y. Alright, it's that number line stuff. Remember last week I said it's not your algebra that's making you stumble with some of these answers, it's your number stuff, your number line. Negative 3, negative 2, negative 1, 0, 1, 2, 3. And if we're at 3, we're here, and we're subtracting 3, we're going 1, 2, 3, we end up with 0. So they cancel each other out. Hopefully you can see that. Okay, what are we left with? 9 subtract y squared. If we did it the FOIL way, it takes that long. Okay, 9 subtract y squared, which is exactly the same as that if we do it the difference of 2 squares way. So we square the first number, square the last number, and just put a subtraction sign in there. Okay? I know it's Monday morning, some of you are alert and up to this, others of you aren't. Remember, this is going up on YouTube. Most of you are still in FOIL, so maybe look back at FOIL, or I'll go through some more FOIL in a second. Others of you that are into this distributive law later, go back and look on YouTube. Okay? Okay. You tell me if I'm going too fast and to slow me down. Okay? The area of a triangle with a base B and H is given by that formula. That's a formula we're familiar with. Over time, you won't be familiar with formulas that you'll be given, but at least this is a familiar one. Rearrange this formula to make H the subject. All right? You should be familiar with that process. All right?
The half was the thing that got me confused.
Okay, so if you were to half divided by 2, do that on your calculator. Half divided by 2, what does that give you? We're definitely going to divide B by B. And a half divided by 2 gives us 1. And that's what we want, isn't it?
Yeah.
We want to get everything to be 1. That's what we're doing here. And that's what we'll do there. So if we were to divide this side by 2 and divide B by B, that would give us 1. And that would give us 1. What we did to the right hand side, we must do to the left hand side. So A divided by 2B equals H.
Okay.
Would you agree with that?
Yeah.
And so we've made H the subject. The moment we've made H the subject,
Why do we need to divide half by 2 again, just to make it 1, like a half?
Yeah. Yeah, because what 1 times 1 times H gives us H,
Yeah.
which is what we want. That's the purpose of doing all of this. You know, when I say, oh, you know, you take it over the other side, really all we're doing is H times 1, we could times 1 a million times, you're still going to end up with H.
Yeah.
Anything multiplied by 1 is whatever you started with.
Yeah.
Okay, so we could always write this, Will. Yeah?
Yeah.
When I tell you that H is 64, well, you times it by 1, you times it by 1, you're still going to get 64. When you times 64 by 1 a trillion times, you're still going to end up with 64. Yeah? You alright with that?
Yeah.
Alright. So now that we've got that, you should take it from there.
Okay.
Because A is 30 on this occasion, B is 6, A is 32 on this occasion, B is 8, A is 19.5, B is 5. Just watch out, you've got
Yeah.
that. But all they're asking is find the height of the triangle, so you're only putting in different measurements for whatever the height of the triangle is.
Yeah.
The next one, when a car travels, when a car travels a distance of d kilometres in the time t hours, the average speed s for the journey is given by that formula. Make D the subject, so again you're rearranging. How would you rearrange that? S equals D over T.
Well, you need, because it's division for T, you need to make it a times.
Yes.
So it'd be S times T equals D.
Excellent, excellent. ST equals D. Yeah. Make D the subject, hence find the distance covered by the car travelling at an average speed. Alright, when a car travels a distance of D kilometres over T time in hours, the average speed. So when 60 multiplied by 3, that'll give us how far it travels, 180 kilometres. Yeah?
Yep.
Make T the subject. So now you've got X equals D over T. Alright, make T the subject. You could almost just stay with ST. ST equals D. We want to get T on its own. How do we do that?
You leave D because it's already there, so you need to make S the, is it the denominator? Or
Yeah. Yeah. Beautiful. That's what we want. T therefore equals D divided by S.
Yep.
Yeah.
Yep.
And then you roll from there.
Right, cheers.
Alright. Okay, so where we need to go with this one is to just separate them and use that as our foil to start with. Okay, and then this becomes our distributive law 1. Everything outside of the brackets is multiplied by that which is inside the brackets. Okay, so we go first outers, inners, and last. You okay with that so far? And then we're saying multiply everything by outside by that which is inside, so it's plus 2x, take 4. Plus 2x, take 4, and then a case of collecting like terms. There's no other x squared, so x squared has to be on its own. I've got an x plus 5x plus 2x, that gives me 7x, that gives me 8x. Numbers are like, and I might go through and I might do this. Got rid of all of them. That leaves me with plus 5 take 4. If I know my number line, I get plus 1. Any questions with that? You know, here you're using double foils. Okay? And then collecting like terms. With these ones, careful for the negative on the outside. That affects everything else, doesn't it? Okay? So, there might be an example of them back up there which may be useful to look at. Okay?